Introduction. As we know that the concrete is the most widely used construction material worldwide, but its production requires large amount of cement and fresh water. Cement manufacturing contributes significantly to carbon dioxide emissions, while excessive freshwater consumptions place pressure on natural resources. To address these environmental challenges, sustainable materials such as fly ash and treated wastewater can be used in concrete production. Fly ash act as a supplementary cementitious material, so reduce the cement consumptions, promoting the reuse of industrial waste. Similarly, secondary treated wastewater can be used as an alternative to potable water in concrete mixing. However, the predicting the mechanical properties of such sustainable concrete mix in complex due to non-linear interaction among different material machine learning techniques provide a powerful data driven approach for the predicting compressive concrete strength. Machine learning techniques provide a powerful data driven approach for predicting concrete strength accurately. Therefore, these research investigate the mechanical properties of concrete prepared with fly ash and treated wastewater and apply machine learning models to predict compressive and flexural strength. Now we will discuss the research objective. What are the major points in my research? Research objective. The first objective is to evaluate the workability and the mechanical properties of the concrete prepared with fly ash and treated wastewater. Second one, to analyze the influence by fly ash replacement level on compressive and flexural strength. Next, to develop the predictive model using machine learning techniques to compare the performance of different machine learning algorithms and identify the most accurate model. Now we will discuss the material which is used in my research. The material used in this study include the ordinary Portland cement which is grade 43 as per the IS 12269 2013, granite based fine and coarse aggregate. Class C, fly ash as a partially replacement and four different waste water sources including tap water and secondary treated wastewater collecting from the three treatment plants Blender, Jakar and Belendur, Jakur and Nagasandar in Bangalore. The treated wastewater was analyzed to ensure it may the applicable acceptable limits specified in IS 456 2000. Mix design. Concrete was designed for the M30 grade according to the IS 10262 2019. 16 different concrete mix were prepared using four water types and four fly ash replacement levels 0%, 10%, 20%, and 30%. As we know, the water cement ratio and the aggregate contained were kept constant to maintain the consistency of the experimental analysis. Now we'll discuss the experimental testing. There are three major tests testing to evaluate the properties of concrete. First one is workability test, second compressive strain, and the third one is flexural strain. In workability test to slump test was performed according to BSEN 1235022 to measure the consistency and the flow characteristics of the freshwater concrete. Second one, the compressive strength cube specimen. Cube size is 150 mm into 150 mm into 150 mm. Were tested at curing is 7, 14 and 28 days. Following also the BSEN 123903 standard. In flexural strength, the beam specimen were tested under 2-point loading condition to evaluate the flexural performance of the concrete. Now we'll discuss the methodology of the machine learning. In my research, a dataset of the 588 sample were developed using experimental result and the data collection from the relevant public literature. 6 input variables were considered: cement contained, fly ash contained, fine aggregate, coarse aggregate, water type, and curing age. 2 in output variables were predicted: compressive strength and the flexural strength. The dataset was divided into training and testing subset using 70% and a 30% splits. 5 supervised machine learning models were implemented: linear regression, lasso regression, decision tree regression, random forest, and the multi-layer perceptron. Now we'll discuss the model evaluation matrices. The prediction performance of the machine learning model was evaluated using 4 statistical matrices: mean square error, root mean square error, mean absolute error, and the coefficient of determination. Lower error values indicate the better prediction accuracy, while a high R square value represent a strong correlation between the predicted and the experimental result. Now, the key result of my experiment: the workability decreased slightly when treated wastewater was used, but improved slum values, and tap water mix low slightly higher compressive strength and flexural strength. In all, the concrete mix achieved the target M30 strength at 28 days. Among all the machine learning models, random forest regression achieved the highest accuracy in predicting compressive and the flexural strength. Next major contribution of this study: the research demonstrates the sustainable concrete can be successfully produced using fly ash and secondary treated wastewater without compromising structural performance. In addition, the application of machine techniques enable accurate prediction of mechanical properties, reduce the need and the extensive experimental testing. The random forest model was identified as the most reliable algorithm to predict compressive strength in this study. Now we'll conclude my presentation. The conclusion of the presentation is: the integration and the sustainable materials such as fly ash and the treated wastewater with advanced machine learning technique offer a promising approach for the developing environmentally friendly and resource efficient concrete. The study confirmed the machine learning models, particularly random forest, can effectively predict the mechanical properties of the concrete and support optimized mix design in modern construction practices. That's all. Thank you.